Hi, I'm Francisco, a postdoctoral researcher at the University of Twente. My group focuses on creating disease models, and I want to talk about our idea of combining standardization and bioprinting techniques for advanced disease models. The problem we are trying to tackle is osteoporosis, a disease that causes increased bone fragility and bone fractures. More than 30 million people are affected in Europe alone, and this number is expected to rise in coming years. To test for new therapies, animal models are still widely used, but both the anatomy and metabolism are very different from human patients, and their use raises a lot of ethical issues. So how can we improve effectiveness of disease models without having to rely so much on animal experiments? A better alternative would be to use devices like these, to build human disease models that fit in the palm of your hand. Organ-on-a-chip platforms like this allow us to replicate the 3D structure and organization of human tissues with a high degree of fidelity and control over the culture conditions. However, these devices are mostly used for research purposes and are not yet widely adopted by industry and regulators. We think that designing organ-on-a-chip based in existing standards for microfluidics early on in development would facilitate adoption in drug development pipelines. In our project, we want to combine standardized design with advanced technologies such as bioprinting to create a bone-on-chip model for osteoporosis. Through bioprinting, we will take advantage of precise deposition of cells to replicate the organization of the bone environment, and this way build a more predictive, humanized osteoporosis model. The standardized design in a modular fashion will allow for parallel operation and facilitate its inclusion in drug development assays, where these tiny devices can have a big impact.